All right. Okay, let's get set up from the current slide. All right, before we get going today, we are recording now. Let me go over a few announcements, and these are pretty important, folks. Okay. First and foremost, have you done the student course evaluations? Yes. 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 Not yet. To there. Yes or not? Okay. Please, Elsa, have you? Okay. Please. Huh?
Oh, when was this class end?
I can't hear.
I know we talked about it before, but this Thursday?
I can't hear.
I was asking when this class ends.
Oh, Thursday's the last day of class, and then your final is, I'll give you the final on Thursday, and you turn it in to me anytime next week.
Oh, so we don't have to be here next week? It's just fine.
You don't have to, except to bring the final by. And you can bring it anytime you want to. Let me go over that before we leave.
Okay,
I mean,
thought we were going to be in class next week.
Well, I could give an in-class final, but I decided to go and let you do it. Take home. Yeah, you don't like that? Okay, all right.
I'm shaking my head like I don't want to be here if I don't have to.
What? You just don't enjoy being here? Oh my goodness. It hurt to the core here. Okay. Elsa is here. Though she doesn't want to be. Okay. All right. All right. So, first and foremost, I'm saying this mostly for people who aren't here. Please do the student course evaluations. Okay? Number 2, do y'all know what next Tuesday is? Columbus Day? I think not. That's October. The voting day for the Senate seat. Okay. Please, if you're 18.
What time is the...
All right. Brittany's here. The final? No, I'll get it out Thursday. Okay. Now I gave a test to some. You got all the tests. You got all the first 3. Okay. What's that? I'm pretty sure I have. Yeah. Okay. All right. Let me say again, have you done the student course evaluations? Excellent, excellent, excellent. Please, everybody, do the student course evaluations. And this has nothing to do with the course, but I also encourage you, please, if you are registered to vote in the state of Alabama, please vote on next Tuesday. I know it's finals week and all like that, but please don't forget to vote. That's one of the most important things we can do as citizens is exercise our right to vote. All right, now let's go over a few other things. This class, of course, one of my best classes, and barely half the people have turned in their research paper. Listening? Yep. Only about half the people have turned in their research paper. Please get those in, because after Thursday, you start losing points, okay? You get your score up until Thursday, but after Thursday, you start losing points, okay? And first test, everybody but one person, and I thought she wasn't coming back. She showed up one day last week or week before sometime and said she was going to catch up. I still can't return anything until I get her tested, okay? And that goes for test 2. Test 3, I have uno. Only one test 3 has been turned in. So please, folks. Oh, you did? Okay, I may not have graded it yet. Sorry. I've got 2 turned in. Okay. All right. Let's see. One? Yeah. All right. 1, 2, 3, 4, 5. Just enough for a basketball team. Okay. Again, let me say this again. I'll say every time someone new comes in, have you done your student course evaluations? No. Please do them. Please do those. They're really on us to get those done. All right. Please vote next Tuesday. Please vote next Tuesday if you're registered to vote in the state of Alabama. Please vote next Tuesday. Please get your research papers in by Thursday. If you don't, you'll start losing points on the papers. Everyone here, in fact, all but one person in the class has turned in the first test. I thought she wasn't coming back, but she did come back and said she'd get it to me. I haven't gotten it yet. But test 2, most of you have turned in, but not all. And test 3, only a couple have turned in test 3. So please get those in. On Thursday, I will be giving you test 4 plus the final exam. They'll both be shorter than your other tests are. Okay? And this is, gotta find you. Taylor, right? Yeah. All right. I'm going to say this every time someone new comes in. Have you done your student course evaluation?
No.
No, please do those. Please do those. They're really on us to get those done. All right. And if you haven't turned in your, oh, and by the way, also next Tuesday, if you're registered, please vote. Yeah. All right, Senate seat, got to vote. Okay. Number 3, if you haven't turned in your research paper, it has to be in by Thursday, otherwise you start losing points. Okay, so please get that in today or tomorrow or Thursday morning, but please get it in. Your first test, all of you present have turned them in, but one person still hasn't. She's not here and yet, so hopefully she'll get here. And test 2, about half of you, maybe a few more than half have turned in. Test 3, only a few have turned those in now. Okay? So please get those in. And then on Thursday, I will be giving you your Chapter 6 test, which will be very short, and your final exam, which will be very short. So you'll have 1 week to do those. You can get them done probably in less than a week, but please get them back to me by, sometime during final exams a week. Now, let me go over schedule for the rest of the term. Again, my office hours on Tuesday and Thursday are 1:15 to 3:15, today and Thursday. On Wednesday, tomorrow, is 3:15 to 5:15, and all those are here on Bessemer campus. On Friday, I'm on the Birmingham campus, 7:45 to 11:45, including this Friday. Now, next week, once finals start, then everything sort of messes up a little bit because final exam schedule classes don't meet the same time that regular classes do. So let me tell you what my schedule will be next week. On Monday, I'm actually doing a review session for my Math 100 class from 8 to 9:50. So I'll be here in the classroom, but I'll be doing a review session. Okay? And Chasten is here. All right, and Whitney's here. All right. Sorry, I'm going to go over this every time. Have you done your student course evaluations?
I started.
Started.
I'm
Yeah.
finished.
All right, good deal. Please get those done. Okay. And please get your research papers in if you haven't. All of you have done the first test, but not everybody has, so I've got still waiting on one person there. About half of you have turned in the second test, so please turn those in. And only a few of you have turned in test 3. Please get those in. All right. Coming up Thursday. Okay, I went through my schedule. Coming up Thursday, first thing in the morning, when you come to class, I'll be returning all your tests to you. So that means that's the last chance to get a test turned in. Because if you haven't turned it in by then, I have to give you a 0, okay? You've got to get those in by beginning of class on Thursday. So that's test 1, test 2, test 3. All of you have done test 1. Most of you have done test 2. But test 3, I need them in by then. And then at the end of class, I'll be giving you the Chapter 6 test plus the final exam, and you'll have any time next week to turn it in. Your research paper is due by Thursday class. If it's any time after Thursday's class, you start losing points. Okay. Now, I was going over my schedule for finals week. Monday morning, 8 o'clock until 9:50, I will be in this room doing a review session for my Math 100 class. So you're welcome to come in and listen to that or work on tests, but I can't answer any questions for you then because I'll be doing a review session for them. Okay, but from 9:50 on, the rest of the day until 5:15, I'll either be in my office or in some classroom between my office and this room doing, if anyone comes in to make up an exam, I'll be in one of those classrooms between my office and here giving those exams. So I'll either be in my office or in some classroom in between. Okay, Tuesday, I've got an 8 o'clock class that will be taking an exam here from 8 o'clock until 9:50. So they will be in here. It's a pretty good sized class, but there will be some extra desks. If you want to come in then, you certainly can. But I really won't have a lot of opportunity to be answering questions because I don't want to disturb them taking their test. But from 9:50 until the 3:15, I will be available either in my office or some classroom in between my office and here. Okay? At 3:15, because it's a second mini-term class, we still have class next week on mini-term classes. So at 3:15, I will be in a class in this room from 3:15. I doubt if we'll go until 7:45 because we'll probably finish early, but technically it's scheduled from 3:15 to 7:45. So don't plan to see me with anything then unless it's on the back end of that and they've already finished their last lab and that kind of stuff, and they may be gone, then I'll be able to answer questions then. Okay, Wednesday through and Thursday. Wednesday and Thursday, I should be either in my office or in some classroom in between my office and here all day long. Wednesday, 7:45 to 5:15. Thursday, 7:45 and, well, okay. At 3:15, I give my last final for the mini-term class. It will not take long. I should be back in my office or in a classroom in between by 4 o'clock because it's not going to be a long final for them. So you can catch me somewhere either in my office or some classroom in between here and there anytime Thursday after, say, 4 o'clock. Up until 3:15 and after 4. In between, I may be up here in the classroom. All right. Friday, I'll be on the Birmingham campus, 7:45 to 11:45, just like I will this Friday. So if you do come to turn something in, please get it done then. I do need everything turned in next week, during finals week. Because I can't remember now when grades are due. They usually are Monday, the following finals week, by 12 noon. If that's the case, I've got to have everything in by Friday, please. Now, if they give us an extra day, and they did that one time until Tuesday at 12 noon, you may have another day there, but please get everything in. Let me tell you this too, especially those who aren't familiar with the system here. We have an archaic system, okay? This student suite, you can access now, right? Anytime you want to. Not during finals week. because there's only something like, this is unbelievable, 16 ports or portals out there. And if they leave it open for students, all the students are checking their grades, and they clog those portals, we can't put the grades in. So what they do typically during finals week is shut down Student Suite. You cannot access Student Suite during finals week. You can access Blackboard. I always put the grades in Blackboard before I put them in Student Suite anyway. So please check during finals week, check your grades by way of Blackboard, not Student Suite. Once finals week is over with, then you'll be open again. After that noon deadline, whenever that is, that we get our grades in, after that, Student Suite will be open again. So don't be trying to access your grades during finals week. You won't be able to. Okay. That's all I can think of. Any questions? Okay, I will be returning all papers to you, so I've got to have them in today, tomorrow, or before class on Thursday. Okay? All right. If there are no questions, we were on the top of page 412, chapter 6, additional topics in trigonometry, 6.2, law of cosines. And we had just done example 1. And in example 1, we said always go for the largest angle first with law of cosine. Okay? And the reason for that, they show here, knowing the cosine of an angle, you can determine whether the angle is acute or obtuse. Okay? If it's an obtuse angle, the cosine is going to be negative, because cosine is negative in the second quadrant. Okay? So, you know where you are. If the largest angle in the triangle has a cosine that's positive, then you know you've got a large acute angle. But if it's negative, it's an obtuse angle. If you go for the smaller ones first, you may have a couple of options there. The biggest one, you don't have any options. It's going to be whatever it turns out to be. So in example 1, once you knew that angle B was obtuse, you knew that the angles A and C both had to be acute. No question about it. Furthermore, if the largest angle is acute, then the remaining two angles are also acute, but they have to be smaller, of course. Okay. So remember that for law of cosines. Always go for the largest angle first, if you have an option. Okay. Then we go to example 2, and they don't show example 2. So let's go back and do example 2 here. All right, let me get my pen set up. Bless you. Okay. Find the remaining angles and the side of the triangle shown below. Okay, I'm going to try to draw it here. My drawing is not very good. I'm going to go A to B here. Here's A, here's B, and that side is C equal 12 meters. Okay? They give you angle A being 25 degrees. Now mine may not be drawn to scale. Okay? Excuse me. Okay? And side B here is 9 meters. Little b is 9 meters. And this is angle C. And we're looking for side A. So we have two angles we don't know, and we have one side we don't know. How can we proceed with this? Will law of sines help us here? No. For law of sines to be useful, you have to know a ratio. An angle and the opposite side. One of those you have to know. We don't know that one, we don't know this one, we don't know that. We know one thing about each one of those ratios, but we don't know two. Now, if you had known two angles, you know all three angles. So if you know any side then, yeah, you can use the law of sines. But if you only know one angle and don't know its opposite side, you cannot use the law of sines. So we have to use law of cosines. Now remember, it has two different forms. Which form would you want to use in this case? Or you can write down any one of them. Give me the law of cosine, however you remember it. Anybody remember? I know it was a good 3 or 4 days ago that we did it. Law of cosines. Help me, help me. Anybody know? Law of cosines. Okay, say that again. A squared equal B squared plus C squared minus 2 BC, is that right? Times the cosine of A, capital A. All right. That looks like the way to go too, folks. Okay. Now, law of cosines should be fairly easy to remember. It basically looks like Pythagorean theorem to begin with. The first 3 terms are written this way. Only thing is you subtract from that twice the product of the square roots of these, B times C, and the cosine of the angle of Q. That's the law of cosines. So this is going to give you how to get side A. Well, actually, it gives you A squared. So let's plug and chug. What do we get? A squared is equal to what? 9 squared, which is 81, plus 144, that's C squared, minus 2 times, that's 108, isn't it? That's 216 times the cosine of 25 degrees. Do you see how to get it? B is 9. And 9 times 12 is 108, right? And twice 108 is... okay. All right, so if someone has a calculator, punch away, folks. And what we surely hope is going to happen is that A squared comes out positive, right? If it doesn't, you're in serious trouble. Because A squared can never be negative. What do you get A squared to be? Anybody? Anybody? What's that? And what is it? Oh boy, you really got a negative number. We're in bad shape then, aren't we? Okay? Let's try it one more time. 91. Okay. It's 81. I said 91. 81 plus 144 minus 216 times cosine of 25. So you see 81 plus... Second? Okay, 29.2375 is what the book had. 29.2375 or something like that. Okay? But we really don't care what A squared is. What we want is A. So what would A be? Anyone want to make a ballpark guess? Between what 2 integers? Between what 2 integers? If A squared is 29.23 blah blah blah. Between 5 and 6. So 5 point what? 4 blah blah blah. I'm just going to leave it as 5 then. 5 meters. Okay? Because you only have one significant digit for 9. How can you get any more? Okay? So I'm going to leave it that way. The book carries a lot more digits than I do. Okay? Now, that only gives you this side. This is approximately 5 meters. Okay? Where do we go from there? We still got 2 angles we don't know. How do we get those? Second? Now you law of sines, because you do have a side in its opposite angle. Now here's what I would do, folks. If you have that on your calculator, now I rounded it, sure enough, to 5. But if you have that whole string of numbers there, leave it there, okay? And then set up your law of sines ratio. What would that law of sines ratio be? A over sine A is equal to which? Okay, B over sine B. Okay. Now, I put little capital B, that should be a little b. Okay. All right. We know little b, okay? We don't know capital B, sine B, okay? So, we're solving for sine B. So, sine B, sine capital B, is going to be B sine A divided by little a. So, if you have that A here in your calculator already, save it or whatever, do or 1 over that, that's what I would do, 1 over that times B times the sine of 25 degrees. B being 9 meters and capital A being 25 degrees. Plug that in, see what you get sine B to be. Sine B to be. Oh, and by the way, before we go any further, did this make sense for A to be only 5 meters? It sure looked like this was the smallest angle. Now, my drawing may not look like it, but in the book it did, and the A was the shortest side, so yeah, we're comfortable with that. Okay? What do we get sine B to be? Anyone got it? Anyone? B is 9 meters times the sine of 25 degrees divided by whatever that 5 point blah 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 was. I'll let you fill in that. They gave us at least 5.4072. You probably had more digits than that on your calculator. I would use all those digits. Whatever it wound up with there when you took that square root, use all those digits. What do you get sine B to be? 0.70. Okay, blah, blah, blah. They got 3/4. How do you get what B was, capital B? The what? Inverse sine, exactly. Take the inverse sine of that, and what do you get? Be sure you're in degree mode because they gave you A in degrees. 44 what? 0.7. Let's call that 45. Okay? So I'm going to call that 45, about 45 degrees. Because they only gave you A as 25. How can you get more precision for B? About 45 degrees. All right. Now, do you use law of cosines or law of sine to get the last angle, C? What's that? Yes, you don't need either one of them, do you? Add the two together, 45 and 25 would be 70. Subtract that from 180 and you get 110. Is that right? Yeah. So angle C, you don't need either one of them, is approximately 110 degrees. Okay, good deal. And let's see, Terrell came in. Okay, 4, 5, 6, 7, 8, 9. Yeah, got it. All right, does everybody see how to work then? Okay. Now the book carries a lot more digits, so I think they're justified to carry, but we we still got up pretty close. Any questions? Now notice on this one, you had no choice. You couldn't go for the big angle first, okay? You have to give what it is. When you had this form of saying, the only thing you could go for is find out what little a was. Your only choice there. When you had three sides, always go for the big angle, okay? All right. Remember, there is a checkpoint, so if you need refreshing, go back and do the checkpoints. I think those answers are in the back of the book, too, for all of them. All right. Any questions before we move on to applications? All right. Under applications, we're going to baseball, okay? A bit early in the year for that. The pitcher's mound on a women's, not baseball, softball. On a women's softball field is 43 feet from home plate. There it is. Okay? By the way, it's not halfway between home and second. It's a little further back. Okay? So it's more than halfway. And the distance between the bases is always 60 feet. 60, 60, 60, and 60. Okay? As shown in this figure. Now, I don't know the precise definition of a diamond. We always call it a baseball diamond, but these are all 90-degree angles here. All 90. I think of a diamond as being either elongated or shortened or something, but maybe this is still a diamond. I don't know officially what it is, but this is actually a square sitting on this one point, okay? So that's what we've got. The question is, how far is it from the pitcher's mound to first base? So when that pitcher fields a ball, how far does she need to throw it? This. Okay? So we're looking for H. Now, if you pay close attention to it, you'll see why they chose the letters the way they did. I think it's a little bizarre, but it's okay. Now, you know the pitcher's mound is in between home plate and second, so you know that angle's got to be 45 degrees because this is 90 down here. So that is a 45-degree angle. We know that. We know this distance is more than halfway from home to second, so we know that's not a right triangle there, okay? They named this H because this was home plate here, the side opposite was little h. This is first base, they named that capital F there, the angle, so they named this side over here 43 feet F, okay? The pitcher's mound here, so they named this P. Frankly, I would have named them what they were. I would have called this the first base line, the pitcher's mound, yeah. But they did it this way, it's perfectly fine, okay? How do you find out what H is? Can you use law of science? No. Why not? You do not have a ratio you know. You know one angle, 45, but you don't know its opposite side. You know this side, but you don't know its opposite angle. You know this side, but you don't know its opposite angle. By the way, this isn't 45 here because the pitcher's mound is a little further back. It can't be. If it was right between first and third, then you would know that. That would be easy. That would be a Pythagorean theorem. That's all you would need. This isn't. They told you that to begin with. The pitcher's mound is not halfway between home plate and second base, so therefore it's not in line with first and third. Okay? So, what are we going to have to use? Help me help. Help me, help me. What are we going to have to use to solve that? To find out how long H is. That's the question. How far is it from pitcher's mound to first base? And that's this measure they're calling H. The which? Okay, we're going to use law of cosines. And how does it go? Say again? How does it go? Using the symbols they're using. Anybody? What's that? Okay, that's what I was saying before. They renamed these rather bizarrely. They named this angle down here H because it's at home plate. This angle over here F because that's at first base. They call the P because that's at the pitcher's mound. Those are your three angles. Your sides are F because it's little f opposite first base is 43 feet. They gave you that. They told you the base path was 60 feet, so that's the side opposite the pitcher's mound, which is little p. They're asking you what is the distance from pitcher's mound to first base. That answer is little h. That's what we're looking for. We don't care about that angle. We don't care about that angle. We're looking for h. So how do we get that? Anybody? Earth to class, come in please. Okay, okay, h squared is equal to, good start, p squared, is that what you said? Plus, a little louder, f squared minus 2 pf cosine h. Very good. Okay? We're looking for h. Actually, we're looking for h, but we need to get h squared first. Your p was 60 feet squared, so that's 3,600. Plus, I don't know what 43 squared is, so I'm going to put 43 squared. Okay? Minus 2 times that. That would be 1825 minus 2580, I believe, times the cosine of 45 degrees. And I think I know what the cosine of 45 degrees is. Do you? So someone punch in the numbers and tell me what you get. What do you get h squared to be? Approximately, anyway. 1,800, and they actually say 0.3. I don't know why. That doesn't really matter much, but we're really interested in what h is. Right? What is h going to be between? Basically between 40 and 50. Closer to 40. And what do you get it to be? Okay, about 42 feet. Okay, now they do 42.43 feet. I don't think you have the precision in the problem to come up with that type of precision here. So while this is 43 feet here, is 42 feet and a change there. So not much further, shorter, but just a little bit. So if the pitcher's throwing that far to home plate, she doesn't have to throw quite as far to get to first base. Okay? But she's probably going to throw that overhanded, not underhanded. Okay? But we'll see. All right. Any questions on that? All right. Good deal. All right. Here is their rendition of it. And that triangle, home plate, the pitcher's mound to first base, H is 45 degrees. That's the only angle we know. And we know that because the HP bisects the right angle at home plate. So we know that's 45 degrees. Your F was 43. That was given in the problem. And also we know that P is 60. That was given in the problem. Jeremy, right? All right. Now let me say again, I've said I'd say this every time. Has everybody done the student course evaluations? No? Please do them. Please do them. They're really on to us to get those done this term. So please do the student course evaluations. Number 2, be sure you get your research papers in before Thursday, or else you start losing points. If you haven't done it already, get it in before Thursday. Number 3, I'll be returning every test to you, not your research paper, but every test to you on Thursday. That means if you haven't turned in test 2 or test 3, get them to me today or tomorrow or before class on Thursday. Okay? So get those done. And I will be returning to you after class on Thursday your Chapter 6 test. It'll be very short. And your comprehensive final exam, it will be very short. Okay? Each of them a page or less. And they will be pretty straightforward. Okay. And Mike, right? All right. And you'll hear it again now. Have you done the student course evaluation?
For some of my classes, I just haven't did it for this one.
Okay, please do it. Please do them for all of them. Okay? What's that? You get to feel real good about yourself. Okay? No, frankly, I know the dean pushes that you give extra points. But frankly, it seems like to me that's bribery. And then I'm not certain we're really getting a fair evaluation. I'd rather you do it just because we're asking you to do it. Please do the student course evaluation. Okay. All right. I also have heard people threaten. You can't take your final exam until you do your student course evaluation. I don't believe in bribes or threats. I just want to ask you to do them. Please do. Okay. All right. Because on either of those cases, you might get inaccurate things. If someone's basically paying you to do it, you're probably going to give them better than you really otherwise. If they're threatening you, you're probably going to have a pretty negative attitude. You may give them a worse evaluation. I want a fair, honest evaluation with no strings attached. Okay? Please do it. Please do it. Okay. All right. Continuing this is our softball field. The H was 45 degrees. They gave you F was 43. That's from home plate to pitcher's mound. And the base path was 60 feet. So, the law of cosines is the only way to go. The H squared, the side opposite the angle you know, squared is first base squared. It's the distance from home to pitcher's mound, which is opposite first base, squared. Plus P squared, that's the base path, which is opposite the pitcher's mound, squared, minus 2FP times the cosine of home plate, which was 45 degrees. That half angle is 45 degrees. Okay, you plug that in, and that gives you 43 squared plus 60 squared minus 2 times 43 times 60 times cosine 45. That gives you about 1,800.3 feet squared. And then take the square root of that, and you get about 42 feet. Almost 42 and a half feet. Okay? Now, before we go there, let's do example 4. All right. A ship travels 60 miles due east, 60 miles due east, okay? And then adjust its course as shown below, okay? And it doesn't show you how it adjusts it. It just shows that it goes another 80 miles this way. But it doesn't tell you how it adjusted its course, okay? After traveling 80 miles in the new direction, the ship is 139 miles from where it began. point of departure. It says describe the bearing from point B to point C. Okay? They named this A, this B, and that C. So they want the bearing here. They want what this is. Okay? Now, they told you this was due east, and they showed you the rest of it. They gave the compass rose there. What will be the letters that are going to show up in that bearing? Huh? Okay, yeah, they will be in there, but the letters as far as directions go. It's going to be north, so many degrees east. So you know the letter is going to be north, blank, east. Okay? We got to come up with what the blank is. Okay? Now, how do we do that? And this is what's going to fill in the blank. Okay? And Doc is here. All right. I'm going to say it again, folks. Okay? Have you done the student course evaluation? No. Please do those. They're really, really pushing on us to get those done this term. So please get the student course evaluations done. Number 2. I'll need all your research papers in by Thursday, otherwise you start losing points. So if you haven't turned in the research paper, get it in to me today, tomorrow, or before class on Thursday. Okay? Number 3. I've gotten all of you, one person hasn't turned in test 1, that's why I haven't returned it yet. I thought she wasn't going to show back up. She did show back up, and she said she turned it in. I haven't seen her since. So, as of Thursday, at the beginning of class, I'll return all your old tests to you. I can't return your research papers periodically. They ask for samples of student writing. So at that point, if I don't have your test in, now I've got all yours in for test 1. I don't have all of your test 2s in. Most of you I do have, but not all. Test 3, only a few people have turned that in. I need those in. Okay? You can turn it in on Thursday, but you just won't get a score until later. So please get those in as soon as you can. And then also on Thursday, I'll be giving you test 4 and the final exam. They'll both be take home and you can go. But that'll be at the end of the period because I don't know how far we're going to get into the chapter before we end. Okay? So I will give you those last 2 tests. But they are very short, much shorter than your first 3 tests have been. Okay. Does anyone else know what next Tuesday is? Voting day. Okay? If you're registered to vote in the state of Alabama, please vote for that Senate seat on Tuesday. That's 1 week from today. Now, I told my first class, I'm here until 8 o'clock on Tuesday evening. That means I can't vote on my way home. Polls are closed at 7. So I've got to vote on my way in. And I may actually be late coming in Tuesday because I'm going to try to be there before 7 o'clock, but they don't open until 7. But if the line is long, I'm going to try to be near the front of the line. Hopefully I'll get there in plenty of time, get here in plenty of time. I hate for it to be during finals week, but please vote, people. Please vote. Okay. Now, so we've already determined our answer is going to look something like north blank east. Okay? We got to figure out what the blank is there. How in the world are we going to do that? What's the name of this section? Law of cosines, of course. And how would we do this? This is the other form of it. How would this go? Someone tell me. A little louder. Okay. All right. Now, which angle are we looking for? B. So therefore, we want our first square to be b squared. Okay? So say that again now. B squared. Oh, you're doing plus a squared. Okay. All right. All right. I was thinking you were going to say it a different way. Okay, if you turn back to the law of cosines, okay, we're doing the alternate form, and so I was hoping we would lead off this way. Okay? All right. We're looking for angle B, so we're going to do cosine B, capital B, that's what we're looking for, is equal to, you tell me what to do from there. You may have been saying it right before, say it. What? A squared plus C squared, absolutely, minus B squared over 2AC. Got it. Okay. Folks, this is the important thing. Now remember back when the first example we did, we said you always, when you're going for the, when you have three sides and looking for the angle, you need to go for the big angle. And that's exactly what we need here. That's the one we had to go for here. Even if they were asking for this angle, you go for B, then later figure out what the angle is. Always go for the big angle. So this is how we're going to begin. What would you plug in where? Okay, this 80 is your A, 60 is your which? Little c, and 139 is your little b. It's the side opposite, right? So you know that's got to be b, that's got to be a, this got to be c. Okay? So now we can plug and chug. Okay, so a squared would be 6,400, okay, plus c squared is 3,600 minus, I can't do that one in my head, I'm just going to write it down, 139 squared over 2 times 240, 480, right? 4800, right? 60 times 80 is 4,800. Can anyone hazard a guess of what that's going to wind up being? Positive or negative? Big time negative. 139 is far, that squared is way bigger than the sum of these two. How do I know that's negative? That's an obtuse angle, a very obtuse angle. The cosine of an obtuse angle is always negative. So we're going to get a negative number. That's why we go for the big one first. What do you get? 6,400 plus 30. I can do that in my head. That's 100,000. No. 10,000. 10,000. 10,000 minus 139 squared divided by 9,600 equal. What you get? $10,000 divided by 10,000 minus 139 squared divided by 9,600 equal a negative number. What is it? Is anyone doing it? I see a few people, but 10,000 minus 139 squared, divide that answer by 9,600. That should give you a negative 0.97. Is that what you said? Okay. That sounds very reasonable. Okay. Then you do what? Take an inverse cosine of that. And what do you get? Anyone get it? Inverse cosine of negative 0.97 or somewhere thereabouts. I actually got in the book 0.97094 if you want a little more precision. What you get, B to B? Anybody? Inverse cosine of negative 0.97094. Anybody? I didn't know your calculators were this slow. You might want to get a new calculator. What's that? Okay. It can't be that hard to do, is it? You need to be in degree mode, by the way. Anybody? 9.99 degrees? Okay. I kind of doubt it. That looks like a lot more than 9 degrees. Okay. It's the inverse sine of negative 0.97094. You sure you have the negative in there? What you get? Inverse cosine of negative 0.97094. Anybody? Say again? 157, is that what you said? 166. Okay, so she got B was about 166 degrees. Is that what you're saying? Okay, is that your answer for the bearing of B from C from B? No, remember your bearing is north so many degrees east. This entire angle is your 166. How are you going to get this angle over here? Minus 90. Subtract 90 from that. And what does that give you? So your answer is north 76 degrees east. Is that what they got in the book? They got 0.15. I don't believe you got precision to do that. So I'm very happy with north 76 east. Very good. What's that? I can't hear you.
What did they get in your book?
76.15 degrees east.
Mine they subtracted it from 180, 13.86 west.
Okay, is your problem like this? The figure look like that? They may have changed it.
They do.
They what? Oh, okay. That's a different problem. Okay, yeah. They had to go this way. Okay. So yeah, I can see now why we're getting different answers if you were using that. Okay. All right. That's example 4. Feel like it didn't. Any questions on that? All right. Now let's go to the last application here. And that's Heron's area formula. Okay? Now, in reality, the area formula we did before when we did law of sines actually had the setup for a law of cosines. But we did the area because it dealt with the sine. Heron's area formula, however, has nothing to do with a cosine, but it does have to do with three lengths, which law of cosines usually have. The law of cosines can be used to establish the following formula for the area of a triangle. This formula is called Heron's area formula after the Greek mathematician Heron. And I actually remember when I was in high school, which was many decades ago. It's not that funny, okay? It was, they called it Hero's formula because they misspelled his name, okay? It's actually Heron's formula, okay? Given any triangle that you know the three sides, any triangle, just draw out any triangle on the floor, okay? Any one. It doesn't have to be a right triangle. If you measure the three sides of the triangle, you can calculate the area, okay? Even though none of those had to be a 90 degree or anything else. And here's how Heron did it. The area of that triangle is the square root of S times S minus A times S minus B times S minus C. Wait a minute. I know the sides are A, B, and C. What in the world is the S? The semi-perimeter. Add the three sides together to begin with and divide by 2. Half of the perimeter. That's what the S is. And this works. It has nothing to do with the law of cosines, per se. It's just happens to be the formula you use. Okay? So let's find the area of a triangle having the sides of lengths A is equal to 43 meters, B is equal to 53 meters, C is equal to 72 meters. Notice they don't give you any angles. You don't need a single angle. What is Heron's formula? A is equal to the square root of, what was it? S times S minus A times S minus B times S minus C. And you know what A, B, and C are. So what have you got to do first? Say again? Calculate what S is. What is your S? 43 plus 53 plus 72, all divided by 2. Semi-perimeter, half the perimeter. Okay? 43 and 53 are 96, and 72 would be 168, and half of 168 is 84. 84 meters. That's the semi-perimeter. So to get the area, you do the square root of 80 meters times S minus A, which is 43. That is 37. Right? Help me. S minus B would be 80 minus 53. That's going to be 27. And 80 minus 72 is 8 meters. Oh, it's 84. I can't read my writing, can I? So I messed this all up. That's 84. Okay. That's okay. Let's start over. Okay. Sorry about that. It's terrible when you can't write. I thought that was going to come up a pretty small number. Okay. It's 84 meters. And 84 minus 43 is 41 meters, right? And 84 minus 53 is 31 meters. And 84 minus 72 is 12 meters, right? All right. Now, pull out your very fast calculators and tell me what you get as a square root. I can't really do that one in my head, so I'll let you do it. Anyway. Got it yet? What you get? A little louder. What's that? Okay, 1,132. And that would be square meters. Now let's see about those units. Is that right? Well, here you have a meter times a meter times a meter times a meter. That's meter to the fourth power. Taking a square root takes half of that, meter squared. That's a good unit for area. Perfect. Now, that seems like a sort of large number, at least it does to me. Here's how I'm going to do a little check. This isn't a very great check, but a little one. Let's just say the base was this 53 meters. Say that was the base. No, let's do the 72. 72 will be the base. And then your others are going up like that, 43 and 53. So I'm going to say the height of that then would be, let's just say it's 20. That's just a guess. So 1/2 the base times the height. If you did 20 times 72 would be 144. And half of that, 20 times 72 would be 1,440, and half of that would be about 7. So I underguessed a little bit, but yeah, that's decent ballpark. Because the area would be the base, 1/2 the base times the height. So the height must be more than 20. I guess it's closer to 30. Okay, maybe not quite 30, 25 maybe. And half of that would be just about right. All right, good deal. So now we have 3. Let's move on. Oh, let's see how they did it. I think it's pretty much the same thing, but let me clear my writing. And we have S, your semi-perimeter, is 168/2, which is 84. Heron's formula is the area is S times S minus A times S minus B times S minus C. That would be 84 times 84 minus 43 times 84 minus 53 times 84 minus 72, which would be 84 times 41 times 31 times 12. Square root of that would be 1132 is what I estimated, square meters. Okay? So we now have 3 different formulas for an area of any old triangle. The standard old formula was 1/2 the base times the height. Okay? The base you usually know. The height is really a hard thing to get. Hard thing to get. If you have any old triangle there, how do you know where the perpendicular is? It's not easy to do. Simple formula, but not particularly useful. For oblique triangles, now this is anything other than a 90, then it's 1/2 BC sine A, 1/2 AB sine C, or 1/2 AC sine B. Whatever angle you want to use, because your height is C sine A, or B sine B, or C sine B. That, whatever your height is there, okay? Now, that looks like a little bit nicer, except usually you don't know what those angles are. Angles are hard things to measure, okay? You have to have a protractor on the ground. They're not very precise. But Heron's formula, if you got anything you can measure the lengths with, to any kind of reasonable thing, you can get the formula. That's the one to go with. A little more involved, but that's what you use. Any questions on that? All right. That finishes 6.2. Let's do the vocabulary for 6.2. When you're given 3 sides of a triangle, you use the law of blank to find the 3 angles of the triangle. Cosines, excellent. Number 2, when you're given 2 angles at any side of a triangle, you use the law of blank to solve the triangle. Second, 2 angles on any side. What did you say? You may have said it right. I just couldn't hear. What did you say? Someone said something. Earth to class. Someone said something. I thought I heard something. Law of sines. Because if you know two angles of a triangle, guess what? You know all three. Okay? If you know all three angles and one side, you've got a ratio you can use. So there you use the law of sines. Okay? Number 3, the standard form of law of cosine for cosine B is equal to a squared plus c squared minus b squared over 2ac is blank. Standard form for that is blank. What in the world word are they looking for? Oh, I think they want, okay. I think they want you to write out, sorry, this is silly, a squared plus c squared minus b squared. No. I think they want you to write out the standard form. If you go back to page 411, they want you to write b squared is equal to a squared plus c squared minus 2ac cosine b. That's the only thing I can figure they're looking for. Number 4. The law of cosines can be used to establish a formula for finding the area of a triangle called blank blank formulas. Heron's area formula. Perfect. Okay, homework exercises here. Do any of the odds 5 through 11. Those have pictures for you. Then any of the odds 13 through 23. Do any of the odds 25 to 29. Fill in the blank or figure out the blank. Any of the odds 31 to 35. And then using Heron's area formula, any of the odds 37 to 43. There's some with fractions and decimals even. And then they have some application problems, any of the odds 45 through 59. Do some of those. Okay? Then they have some exploration problems, few true false, one true false. Certainly take a look at that. And then there's some think about it, some writing and other things, and even a proof there if you're interested in that. All right. Any questions? 6.2. So let's move on. Oh, no. It can't be. We're out of time. All right. We're going to start next time in 6.3. And we'll get as much of 6.3 covered as possible. Don't know how much we'll get done. Hopefully we'll get most of it. This is all stuff that should be old hat to you, but let's get as much as we can. I wish we had time to get into 6.4. That's going to be useful for you later. I don't think we're going to get there. So let's at least do 6.3. If we can get any into 6.4, we'll try to do that. We'll try to go as quickly as possible through 6.3. So your test, your Chapter 6 test will be 6.1, 6.2, probably 6.3, maybe a little in 6.4. We won't at all get to 6.5, I know that. Okay, and then your final exam will be mostly Chapter 5, Chapter 4, Chapter 5, and a little bit of Chapter 6. Okay, they'll both be short, hopefully pretty sweet, and get them back to me as soon as you can. Anytime you want to get them to me during finals week will be fine. In fact, if you want to get them to me Thursday afternoon, that would be fine, or Friday before finals week, that's fine. I'll give them to you for Thursday morning. Anytime you can get them to me, I'll take them. Please get your papers finished and get your other tests done too. I'll be returning those on Thursday morning. Good deal. See you Thursday.